A very good morning to everyone present here. So, in today's class, we are just going to see about database and model on how a database system works. Okay, so the important model is ER model. So, we are going to see about what an ER model is and what are the functionalities of an ER model and how we can represent everything in an ER model. So in this model, we are just going to see what ER represents. So E represents the entity and R represents the relationship. So we are just going to see how an entity acts and what are the relationship that happens between an entity. Okay. So during this video, entire session, so we will see what are the characteristics, what are the attributes an entity should preserve, and how a database can be implemented as an entity. Okay, so throughout this complete entire session, we are just going to discuss on how it can be used, how the problems or inside an inner model works, and what are the ways in which the communication happens between each and every entity. So starting off with the topics that we're going to discuss here. It's about your entity relationship model and what is an entity set and what is an attribute, what is a relationship between these entities, what are the keys that are available, and what is an entity relationship diagram. How do we represent a entity? Okay, so in which part and how it can be represented? What are the notations that is used in an ER model? All these things are going to be handled in this session. And next, we are going to see about what are the features that is available inside an entity or an relationship between an ER model. Okay, so how each entity is related to one another. Okay, so if you have two items, you have to know how it has been communicated, right? So the entity, the relationship between each and every model has to be discussed in this part. Okay, and we will just see few problems that is associated, how based upon that we can handle the ER model. Okay, so first we are going to see about what an entity relationship model is. Okay, so whenever you're going to store some data, okay, if you have a set of data, if you're going to store those set of data, it has to be in an particular order. It has to be in a very good format. Okay, so any paper, for example, you have a pile of papers in your hand, and in that pile of papers, if you want to arrange it, you usually don't throw it as such, right? So we just arrange it in one particular format. Either it can be in a formatted pattern, or it can be sorted by the date, or it can be which updated copy can be kept at first. So these are how normal things work. Okay, so based upon the same thing, every data that is collected in our day-to-day life is placed inside the database in some particular model, and these data can be called as an entity, or it can be a set, or it can be an attribute, or any kind of information that is required by the user. So when each and every data that is stored, it has to be defined in one particular order or manner. Okay, so each specific individual is called as an entity. It is translated, it is communicated with the other entity via the relationship that is happening. The ER model, also called an ER schema, are represented by the ER diagrams. Okay, so each and every relationship is mapped. Anything you look at it normally or in a theoretical pattern, rather than that, if you look at it in a diagrammatical view, it gives you a clear picture of how it has to happen, and how it can be communicated. The ER modeling is based upon two concepts. First one is the entity, which E stands for your entity and R stands for your relationship. So inside your relationship, if you want to know about what an entity is, it is defined as table that holds the information. If, for example, if you have a college, if you're a student, you are a particular entity. That student entity can hold certain set of information. For example, the name of the student, or which department he belongs to, or the date of birth of that particular student, or where he is from, or he has a permanent address or temporary address. So many information of one particular student can be maintained via the bus route, or any specific thing. If you take also, it is communicated with the student. Okay, so it is connected. Okay, the student is a separate entity, but he is collected with certain attributes. Okay, so many attributes of a student is there. So for example, if student is an entity and college becomes another entity, so they communicate with each other. The entities are in turn related with one another. Those relationship or those interaction between two entities, we call it as your associations. Along with the association, we call them as your relationship. Okay, so the definition of relationship is that it is an association or interaction between two entities. Okay, first one, we are going to see about what an entity set is. Okay, an entity set is an object that exists and is distinguishable from other objects. Okay, for example, they have just given here each customer in a bank is an entity. So same way we saw it, right? So college, when you have college, it does not have only one student, it has n number of students in it. A department can hold so many number of students, 80 to 500, so many number of students can be allocated in one particular um, department. So that particular department becomes an entity. Okay, so same way here, each customer in a bank become entity because they generate hundreds and thousands of data every day during their transaction, or anything they do related with the bank, they create some data. All these data is stored in one particular position, that is tables, and those tables are required, and those are called as the information of that particular entity. Okay, next, an entity set is the entity of a same type. Okay, so it is of the same type. So here, when you communicate with an entity, it is like it has the same type and they share same properties. So for example, if you take a second year student or a third year student or anyone who is coming as an intake to this college, okay, so he will be completing his 12th standard and then entering this college. Okay, so all the same, all of them share a same criteria. What is that? They should have completed their 12th at least, or 10, I mean 10th. So they have some basic criteria. So they all possess a particular property, so they belong to one particular property every time. Okay, these set of informations from one particular source, we call it as an entity set. So all the students together is called as an entity set of the set college. Okay, so here everything in collection, so it can be distinguished from one another. Okay, so this is how an entity set works. And next one is that there are so many number of attributes that are available. Okay, so when we talk about attribute, okay, every entity has attributes. Okay, so if for example I'm taking a person, okay, the person has a name, the person has a age, the person has some value that is associated to him. Okay, so he may be owning certain assets, or he may be working in an organization, or he may have published so many contents in the internet, or he may have so many IDs, mail IDs, or he may be in part of an organization, or he may have Facebook accounts, or he may have. So if you take one person, you can identify that person with so many number of attributes. Okay, so here there are certain attributes that are being listed. One is your single valued attribute. Next one is your multi-valued attribute. We'll see each and every attribute separately. Okay, so single valued attribute, multi-valued attribute, simple atomic attribute, compound or composite attributes. Next is your derived attribute, and other than that, it is your null attribute or optional attribute. And next one is key attribute, non-key attribute, and required attribute. So these are attributes which is related to the entity. Okay, so we'll see everyone separately. So first one is your single valued attribute. In a single valued attribute, it is an attribute with only one value for one particular entity. Okay, so for example, if you take age of a person, that is a single valued attribute. So at this point in time, a person can hold only one particular age. Okay, so for in today's date, if you want to identify the age of a person, so that value can be a single valued attribute. And next one is your multi-valued attribute, the attribute which can have multiple values of the same entity. Okay, so the entity is going to be same, the attribute is going to be same, but the attributes are partitioned into so many levels. So how you can identify that? If an attribute has the name of a person, you can consider name of a person is an attribute. So the name can be single value. I mean, the name can be a multi-valued attribute. Why? Because he might have an initial, or he might have a first name, middle name, and last name. So many things. Okay, one particular attribute which can be divided into multi-values, so that is called as your multi-valued attribute. Okay, so example, you can call your name as a multi-valued attribute. And third one is your simple atomic attribute. Okay, by definition, the attributes which cannot be further divided are called as a simple or atomic attributes. You can consider age itself as an simple or an atomic attribute. So these attribute is a normal integer value. Okay, the example age is normal integer value which cannot be partitioned again, right? So if you, for example, if you want to take the date of birth, consider date of birth, but it has the parts like dd, nn, and yy. It cannot be considered as a simple atomic attribute. It will fall under the category of a multi-valued attribute. And next one is your compound or your composite attribute. Okay, the compound or your composite, the name itself specifies, right? So it is a combination of so many things. So here the attribute can be subdivided into two or more categories. Okay, so if you want to identify a composite attribute, it is otherwise called as your division. So it has n number of divisions inside itself. So those kind of attributes are called as your composite attributes. And next one is your derived attribute. So when I talk about derived attribute, so it specifies that derived attribute is something like you can get an attribute where the derived value, wherever the value is derived. Okay, so it is, you have a value which is superior and you get it from that position. Okay, so if you have an attribute like date of birth, from date of birth you derive the age. Okay, so you need something to calculate the age. Okay, if you want to calculate an age, you should know from which state to which state you have to calculate the age. So it is derived from an attribute, another attribute, and that attribute is called as your derived attribute. Okay, so you have to derive it from your date of birth. So date of birth is going to be your stored attribute, and anything you derive. Okay, so that is going to be your normal derived attribute. Next one is your null attribute or an optional attribute. For example, if you consider a table, okay, you can have n number of columns in your table. Okay, so what are the columns we can have? We can have inside table, you can have name, age, the languages known. For example, you are converting a student's database into a student's basic information into a database. So if you want to consider that as a database, you can have name, you can have age, you can have his place of birth, so many things. You can have an option like languages known, for example, or you can keep predefined options like if you have to know English, Hindi, or Malayalam, or any other languages. Okay, so Telugu or something like that. Okay, a person need not know all the four languages. Okay, he can choose his mother tongue, he can choose English. Other than that, any other option can be left as null, or it can be kept as optional. So those kind of language, I mean those kind of options are left behind, right? So these kind of attribute can be considered as your null attribute or an optional attribute. Okay, so either you can paste values inside it, or you can leave it as such. Okay, it can be blank. It is not necessary that you can have you. It is mandatory that, for example, if name of a person cannot be left blank, right? Every person should have a name. Okay, so that cannot be considered as an optional attribute, but the languages known of a person can be considered as your optional attribute. Next one is your key attribute. This attribute represents the main characteristics of an entity. Okay, for example, the primary key. Okay, here by definition they're giving here key attribute has clearly different value from each element in a entity set. Okay, so for example, you have a group of students. Every other student may have the same name, but the roll number given to one particular student is different from the other. So this is how you identify inside a small group of instruction. But nowadays in our if you want to collect data from whole India, if you want to identify a primary key value, you can consider Aadhaar number as a primary key value, right? So it is unique to each and every individual. It is the no two person can have the same Aadhaar number. No two person can have the same PAN number, right? So same way here, the key attribute is such that it is unique. Okay, it is the main characteristics of one particular entity. Okay, for example, if you want to precisely keep it inside one small group of institution, every person can have an roll number, or every other person can have one particular ID that is associated with them. For example, if he is working for an organization, they can identify with his employee ID. Okay, so if you want to organize it with any other specification, right? So every other thing can be kept or displayed very much. Okay, and next one is your non-key attribute. Non-key attribute excluding the candidate key attribute in an entity set, and are the excuse me, excluding the candidate key attribute in an entity set are the non-key attribute. Okay, so every other attribute in the table is left behind. Okay, so other than your primary key value, so the remaining all the other remaining values is considered as your non-key attribute. And next one is contribute as a required attribute. Okay, so when you consider required attribute, you must have the data because they have the desired or the vital part of the entity. Okay, it is very important, so we cannot miss out that particular required attribute. For example, you're communicating between two tables. Okay, so for example, you have a table named as organization and another table named as employee. When you want to communicate with these two, few values has to be kept as mandatory. Okay, like it has to be very important, and it cannot be removed. So those kind of attributes, for example, the employee ID of a person, it is a required attribute, right? So it has to be, for example, if he is working in a particular organization, the mandatory column will be his name, his employee ID. Along with that, he can have his designation also, which is very much important in one particular organization. So these type of attributes are defined as your required attribute. And next one is just these are the attributes that are associated with every entity. Okay, every entity may or may not have any of these attributes. Okay, so first one is your single valued attribute, next one is a multi-valued attribute, simple atomic, compound or composite, derived attribute, null attribute, key attributes, and non-key attribute, and required attribute. And next we are just going to see about the relationship between these attributes. Okay, a relationship represents an association between two or more entities. Okay, so anything that stands alone need to be communicated with an other entity. Okay, so otherwise it does not make any sense, it does not make any meaning. If you have a table which holds a bunch of records that is needed by an organization or other institution. Okay, so if that does not communicate with the other entity, it is meaningless, right? So the relationship stands in the main part. Okay, so it is represented. Okay, it is represented as an association between two or more entity. Okay, they are classified in terms of degree, connectivity, and cardinality. We'll see what those terms mean. Okay, the relationship set. If a set of relationship is of the same type, then they categorize under a then they fall under a one particular set. Okay, for example, we say meant students are one particular entity, and all the students in one particular organization form an entity set. So same way here, the relationship combined together into a say, if they are of the same type, then they gather together and then it forms a relationship set. Next one is your degree of relationship. The number of entities associated with the relationship is known as the degree of relationship. For example, if an entity is associated with three or more other entities, then the degree of entity becomes a value. So if it is connected to, for example, a student is an entity and student is connected to his organization which he has studied prior, and the current organization in which he is working, the entity number becomes 2. So if he is connected internally, it is meaning that it is connected to two or more other entities. Okay, so if it is two, then the degree of entity relationship becomes two. Okay, so there are certain type of relationships. One is unary relationship, next one is binary relationship, then the ternary relationship and n-ary relationship. So these are the basically available relationships. And next one is your connectivity or cardinality. So what do you mean by connectivity? So whenever, if you try to communicate with any other processes, right, so you have to frame certain position, the number of entities in one entity set. Okay, so how many number of entities sit in one particular set is defined here. Okay, it is which can be associated with the number of entity with other relationship set. Okay, so here the entity set, whenever you form two entity, and the connectivity or the proportion. So for example, one person can connect to n number of entities. So we call that particular term as one to many relationship. So there are so many number of cardinalities that is associated with every entity. We will see everything individually. So next one is that it is one-to-one relationship. So the cardinality we're just going to see is one-to-one relationship. Next, one-to-many relationship, and many-to-one and many-to-many relationship. So here, when you look at this diagram, it depicts an entity as A1, A2, and A3. These three entities are connected to, A1 is connected to B1, A2 is connected to B2, and A3 is connected to B3. So these form a entity set. Okay, so A to B and A to B2 and A3 to B3. So here every one individual is connected. For example, if a entity which is standalone, okay, so he might be connected to one particular entity. For example, if he is in an organization or in school, so he may be connected to that school organization. Okay, I mean school entity. So this is how one-to-one relationship is handled. Next one is your one-to-many relationship. Okay, so one-to-many relationship. How can we identify one-to-many relationship? Here in this diagram, we depict A1 is connected to B1, B2, and B4. So here A1 becomes 1, and the many relationship it has is B1, B2, and B4. Okay, so these are the this is how the relationship is handled. Okay, so one to many relationship happens. So here it has another set of relationship that is also called as one to one relationship. A3 is connected to B3. Okay, in which kind of situation can we identify one to many relationship? If you want to identify one to many relationship, you can take your your role in one organization. Okay, so or you can take you as an organization. Consider, for example, if you are mother of a person, then you stand as a mother at for your child, and you stand as a wife for your husband, or you stand as a daughter for your father and mother. So this is how we relate with one another. Okay, so this is how we can relate with one another. So here we saw one to one relationship and one to many relationship. Next one, we are going to see about the other two sets of relationship. One is your many to one relationship and many to many relationship. So inside your many to one relationship, you can identify that A1, A2, and A5 are connected to P1. Okay, so here many to one relationship happens. You can consider this as your example. So here A1, consider A1 as one particular student entity and A2 as another student entity, or A3 as another student entity. He is just connected to the organization. Okay, so here the organization is B1. Okay, so organization is B1. Or you can also consider an organization can not only hold student, it can also hold the faculty members that is associated with this, the workers who are associated, the office staff who is associated. So an organization holds so many number of entities that is associated. Okay, and next one here is that many to many relationship. So many to many relationship can hold as A1 to B1, and so in this image, if you see, it has A1 is connected to A1 is connected to B1 as well as B2, and A2 is connected to B1, B2 and B5. Okay, it is in turn connected to all these relationships. So, say here you have many to many relationship, and you have one to one relationship and one to many relationship. In this image, if you want to consider, you can have so many cross-cutting images which depicts various kind of relationship that is associated. So these are the main four kind of relationship that we should know. And next part, we are just going to see about keys. Okay, so we are just going to see what is a key, what is a candidate key, and what is a primary key, what is an alternate key, what is a composite key, and what is a foreign key. So, super key. So we'll just start up with this. So here we have super key. So inside keys, the main role or the main important role in a relation database. It plays a very important role in a database. It is used to identify any record or any row of a data, okay, from one particular table. It is the main use of a key is to identify one particular record. Okay, so if you have 100 students or 100 person in front of you, if you want to identify each and every one by their own personal value, so you can identify them with the help of your key value. Okay, so one is your whatever name, or you can have their own IDs that is given to them, or you can take consider their Aadhaar card or any specific value of that particular person that has to be unique. Okay, so it plays a very important role. Okay, for example, we can take your student ID, the SSN number, so many things. Okay, the date of birth of one person or passport number, so many things are there, but it has to be unique. Okay, so here we are just going to see about what are the keys that are available. So first we will start off with your super key. A super key is an attribute that can uniquely identify a record. Okay, so it is help or it will be useful to identify a record unique. Okay, so if you consider in a table, there will be only one record with that value. Okay, so that is going to be a unique value. Okay, so it will help you identify the record uniquely. Okay, here employee ID can be used as your for example, employee ID can be used as your super key in an employee table. Next one is your candidate key. So a candidate key is an attribute or a set of attributes that can be uniquely identified. Okay, either it can hold only one particular value or it can be a set of value. Okay, so here the passport number, license number, or SSN number, all these key values aggregated together or set can be summed up together. All these value candidate key value are called as the candidate key value. It can be combined together and then displayed. Okay, so this set of value or this set of attribute can be considered as your candidate attribute. Okay, next one is your primary key. So primary key, it is the first key that is used to identify one instance of an entity uniquely. Okay, so the basic or the simple ID you can give is that primary key. Any specific or uniquely given ID can be considered as your primary key. Okay, so if you consider person as your table, any person's database, so if you consider the Aadhaar number is going to be your primary key, so that it is unique for that one particular person. Okay, it is unique for each and every entity. With the help of that unique ID only, we will be able to we're able to maintain relationship with other entities. Okay, if you want to refer one particular record from one particular table, with the help of your primary key only, you can identify. Okay, and next one is that you have an alternate key. So when you want to know an alternate key, there may be one or more attributes or combination of attributes. Okay, so you can have only one attribute or a combination of uniquely identified attribute, okay, of each record. Okay, in other words, you can also tell that total number of alternate keys. So you can sum up all your alternate keys. Okay, is the candidate key. I mean, the total number of alternate key is the total number of candidate key minus your primary key. Okay, so if you have three candidate keys, so we saw candidate keys example as your passport number, license number, and your SSN number. Okay, so SSN number or your other number, anything, any particular thing that can be considered as your candidate key. That minus that if you minus from your primary key, the value you can get is your alternate key. So whenever if you are not going to use your primary key, you can use your alternate key. Okay, for another example, like employee relationship has two attributes, right? For example, employee ID, that is going to be unique, and your PAN number, that is also going to be unique. In this relationship, employee ID is chosen as your primary key. Why? Because an organization needs the employee ID for his reference rather than his PAN number. Okay, so here primary key, your employee, for an employee table, employee ID remains as your primary key. The employee's PAN number will act as your candidate key. Okay, so next one we'll just move about composite key. So composite key, whenever a primary key consists of more than one attribute. Okay, if there is more than one attribute, it is called as your composite key. Okay, so or you can also call that key as your concatenated key. So concatenated key, all these keys together. Okay, you can consider that particular value as your concatenated key. Okay, for example, if you have an employee table, employee ID can be there, the role of the employee can be given there, the project ID given there. So these are the values that a person can be identified. So all these values together can be concatenated, and can be considered as your composite key. Okay, it can be concatenated and it can be used. Okay, next one is your foreign key. So when we talk about foreign key, if you use the same primary key in foreign keys are the column that is used to point a primary key of another table. So for example, you have employee ID. Okay, so if employee ID or department ID, consider you have a table called employee and the department he belongs. Okay, so the department ID of one particular table will be the primary key of that particular table. Okay, for example, consider you have a database. Inside that database you store department values alone. So those values are called as your department values. Okay, this value can be kept as your department ID. So here department ID can be a foreign key inside some other table. Okay, so these are the basic keys. So we saw about super keys, candidate key, primary key, alternate key, composite key, and foreign key. Next one is your entity relationship diagrams. So when we talk about your entity relationship diagram, here we use certain number of notations. So when we want to know what are the notations, here we have entity as a notation. Entity's notation is represented in a rectangle frame. Okay, and next is your attribute. So attribute is represented in an ellipse format, and next one is your diamond shaped that defines your relationship. So either it can be weak entity. If it is defined in double line, then you have multi-valued attribute, you have weak relationship. We'll see what are those relationships separately. Okay, rectangles which represents your entity set. Next, eclipse which represents your attribute. Then your diamonds. So we saw all these things, right? So next one is your how we identify. Okay, so here every other shape represents your rectangle shape represents your entity. If it is double rectangle, then we call that as your weak entity. Next, your relationship, your attribute, your multi-valued attribute. If it is a dotted ellipse, then we call that as your derived attribute. Okay, so we saw what a derived attribute, what a stored attribute is. So all these things. So next one, we are just going to see how we create an ER diagram. Okay, so if we want to identify all these entities, okay, inside one particular term, okay, an entity should appear only once in a particular diagram. Okay, for example, if this is going to be your ER diagram, your ER diagram should not have n number of student entity inside it. Okay, it should have only one entity. Or example, if you are having a college as an entity, so n number of college entity should not be there. There should be only one entity that is given inside. Now, next one is your identify relationship between these entities. Okay, so how these two are connected? By a student studying in one particular college, they are connected. For example, if you want to consider teacher who teaches one particular subject. Okay, so if your teacher teaches you some lesson, the teacher becomes one entity, and you as a student, you become a separate entity. They both connect via one particular term called teaching. Okay, so teaching becomes the relationship between a teacher and a student. So each entity has their own attributes. Here in this diagram, if you see that you have a student ID, student name, student address, all these things which is related to one particular student. Here they're just given three samples. Here student might have n number of attributes. It can have his mobile number, he can have his Aadhaar number, he can have his any other specific details like if he has a passport, yes or no, the language is known. All these fall under the attributes. Okay, and the relationship here is defined in your diamond figure, which is like studying. Okay, this is a very simple ER diagram. It should give a meaning. Okay, so if at all you want to create a database with the help of these diagrams, you can identify. If you want to develop an architecture of a database, you can easily identify and bring out the architecture of a database with the help of these values and these attributes. Okay, so here is one simple way of representing. Here I've just given another set for you to understand clearly. Here it is an restaurant system. Okay, here if you, in the basic thing of a restaurant system is that you have a customer table, you have the staff who is working in that particular table, and then the number of orders that happens at that particular time, and the details, order details, whatever order details that is used is given there. And then next you have your items. Okay, so how many number of items that is listed in your menu. So inside your customer table, you can have a table number, number of seats, details, all these things together. If you have an order picked up, then you can have your order ID, order date and time. And if you have a staff, okay, if you consider a staff, the staff can have his own address, his own phone number, and ID, name, and salary given to that particular staff, and the gender of the staff, and the work nature. Either he can be a manager, or he can be a person who serves, or he can be a chef inside that restaurant. So many things can be given in between. Next one is the item. Okay, so here item becomes another entity where item has the so many number of attributes, like item ID and item name, item price, balance, and calories. All these things, images were given to that item. So this is how we depict. Even more attributes can be added inside this particular restaurant system. Okay, so we'll just see another example of weak entity set. Okay, we just saw what an entity set is that, but here we will see what an weak entity set is. Okay, so here when you have a loan as your part. Okay, so loan is going to be the item that we have just used here. Okay, your loan is going to be one particular entity, and payment is going to be another particular entity. Okay, when you look at loan is associated with the loan number. Okay, and loan amount that is given along. Okay, so loan number which is given along. Here loan number is underlined. Okay, so when you identify your loan number which is underlined, you should know that it is a key attribute. So based upon this key attribute, it is going to process its value. Every time when a loan process happens, they will identify it with the help of the loan number. So that is why it is underlined, which means it is depicting that it is a key attribute. And the rest is not underlined, which means amount is not underlined, which means it says that it is a normal attribute, it is not a key attribute. Okay, next one is that it is your loan payment process. Okay, so loan payment process, here it represents your weak entity relationship. For example, if a bank is there, and if the bank has 100 customers associated with them, I mean each customer becomes their own entity, but it is not necessary for all the customers to take a loan. Okay, that makes that loan as a loan payment as a weak process. Okay, for example, or if you can, they will be having loan, but they will not avail that loan if a person who has availed that loan, he has to make the payments on time. Okay, so the payment process becomes a weak entity here. Okay, so it is only required every month. Okay, it is not throughout the, for example, if the transaction, for example, debit is going to be an entity or credit is going to be an entity, so any other time. Okay, so nowadays we use GP, and so many times we touch in with the bank knowingly or unknowingly, right? So every other payment we make, we hit the server, we hit the database for doing one particular transaction itself. Okay, so these processes are mandatory, so that are called as your normal entity, whereas any process which is just being used only for one particular period of time, and it has a relationship with your strong entity, we call that entity as your, that relationship as your weak relationship. Here, for example, in this image, they have given loan payment as your weak relationship and payment entity as your weak relationship. Okay, so here whenever you do your payment number is getting generated, the date of the payment is given there, the payment amount is given there. Okay, so we date of the payment is just given as your one particular attribute, that is your payment number, that is going to be an important attribute for you here. Okay, it is going to be a key attribute. Okay, but key attribute which belongs to a weak entity. Next one is your payment date, that is a normal attribute, and then payment amount is also going to be a normal attribute. Next one is your strong entity set. Okay, so here if you want to use your loan payment, okay, here the relationship between a strong and weak payment entity set is defined here. Okay, so when you process a loan, okay, you are going to you're going to use the relationship as your loan payment when you're going to pay the loan. Okay, from this, when the difference, if you look at this here, why it makes you weak entity, because the payment is related to the loan, whereas here the loan is related to the payment. Every time the payment happens, okay, every month it happens, the payment is getting altered and the loan amount is being submitted. Okay, so loan payment processing is given as an example. So next one second. So this is how your loan payment happens. So your loan payment with the weak entity is described here. When you want to move it with the, how it is communicated with the relationship happens between your strong entity and your weak entity. So your loan happens, and then your loan payment is being processed and the payment happens. So the payment number is going to be given as your important primary number, then your payment data and the payment amount. Okay, so this is how your strong entity is represented. We'll just see the difference between your weak entity and your strong entity. So the basic comparisons of your strong entity and weak entity. Okay, so based upon certain criteria. So the basic criteria is that strong entity has a primary key, weak entity has a discriminator key. Okay, so next one is that it depends upon this, depends how it depends. Okay, so the strong entity is independent, but the weak entity depends on the strong entity for its existence. Okay, next one is that it is the denoted, how every other entity is denoted. So here the strong entity is denoted in a rectangle box, but weak entity is denoted in a double rectangle box. Next one is your relationship. The relationship between two strong entities is denoted by a single diamond. It is denoted by a single diamond, simply called as relationship. The relationship between a weak and a strong entity is denoted by identifying relationship denoted with a double diamond. Okay, so identifying the relationship with a double diamond specifies the relationship. Next one is your participation. Okay, so participation, strong entity may or may not have total participation in the relationship, but weak entity always has total participation in the in identifying relationship shown by double line. Okay, so whenever there is a double line given across, then it is called as your weak entity here. So this is how we clarify your weak entity and your strong entity. So we will see a small problem that is associated here. Okay, so here a small problem I've just given here. So here when you look at this image, okay, so when you look at this image, here you have so many number of entities. So bank is another entity, account is an entity, loan is an entity, customer is an entity, bank branch is a weak entity. Okay, it is associated with a bank. Okay, every bank can have a number of branches, and the branch can have their own IFSC code. They have your branch number, they have your address, and so many things that is associated. So here a simple ER model of a bank is displayed here, and we have few questions that is associated with this model. Okay, first one, consider the ER diagram shown in the figure for part of a bank database. Each bank can have multiple branches, and each branches can have multiple accounts and loans. Okay, so this is, they're just giving a small definition of that particular image, and they're just getting into the question. List the non-weak entity type in the ER model. Okay, so what is a non-weak entity model? A strong entity model is a non-weak entity model, right? So here inside, every rectangle is considered as a, every single lined rectangle is considered as a normal model. Okay, so here bank is a strong entity model, and next one, account is a strong entity model, then customer is a strong entity model, and then loan is a strong entity model. Okay, so here so many models are given here. Okay, so it is a strong entity model. So here in this example, if you see here, you have a normal entity model that is given along. Okay, so here normal entity model, you can consider bank, you can consider your account, your loan, and your customer as your normal entity model. And next one is your, they have asked another question. So here in this previous diagram, you can't consider bank branch as your entity model. Okay, why? Because it is given in a double rectangle, which means it is representing a weak entity. Okay, so it is representing a weak entity, so it cannot be considered as a weak entity it cannot be considered as a strong entity model. It belongs to a weak entity model. Next one, so here in this image, if you see, is there a weak entity type? If so, give the name, partial key, and identify the relationship. Okay, so if, so here they are asking for a weak entity type. So here, which is double bordered. So bank branch is double bordered. So it is a weak entity type, and they're asked, if so, if there is a weak entity inside this, they're asking for the name. Okay, so bank branch is a name, and they're asking for a partial key that is associated. So which is going to be the partial key? So primary key, it is just underlined, right? So here partial key, branch number is going to be your partial key. So partial key is given as branch. Next one is identifying relationship of the branches. Okay, so what are the relationship here? So branch is one of the relationship. Okay, so with the help of your branches, it is connected to the other entity that is called as your bank. Okay, so identifying the relationship. So what are the relationship that is available? It is branches. Okay, so here it is also connected to your loans, but how it is connected? With the help of your weak entity, with the help of your relationship named as branch. Okay, so branch is considered as the weak relationship which is associated with another entity that is called as your bank. Next question, what constraint do the partial key and identifying relationship of the weak entity? Okay, what constraint do the partial key and the identifying relationship of the weak entity type specify in this diagram? So they are asking here to identify the constraint. Okay, here they are asking what constraint is given there. Okay, so here What are the constraint that is given? The constraint of a partial key is your branch number. Okay, that we need to combine with your branch number. Okay, so branch number with the code. Okay, so branch number with the code. Okay, to uniquely identify a bank branch. So for example, if you have a bank in your location, okay, the main branch is considered it is allocated in some other part of the city. Okay, if you want to identify these two positions, here you can identify bank branch. Okay, so combining those two, you form an answer. Okay, so bank branch becomes your constraint here. And next one is the constraint. The next part of the question is that identify the relationship of a weak entity type specified in this diagram. So the first constraint here is that the weak entity set must have total participation. Okay, so the weak entity set must have total participation in identifying relationship set comma branches. Okay, so what are the relationship set they have, and the branches has to be included here. For example, in this diagram they have given branches as your weak entity set. Along with that, bank branch becomes the constraint that has associated. Okay, so it is identifying the particular association. Next, third, the identifying relationship between bank and bank branch. Okay, the identifying relationship between the bank and bank branch must be one to many. Okay, here it has a one to many relationship. So in this example, if we see, we have a constraint given here. One second. So here, if you have, you can identify the relationship between the bank and branches must be one to many. So here, bank, here if you see the relationship constraint given here, it is 1, and when it is represented as n, it is defining as one to many relationship. Next, we move on to the next question. Here, list the name of all relationship type and specify the minimum maximum constraint on each participation of entity type in a relationship type. Justify your choice. So here they are just asking us to identify the relationship. So what are the relationships? So when you look at this image itself, you will be able to identify the first relationship here given as branches, next one as account, and next one as account, next one as given as your customer account, your loan account, and then loan as a specific, I mean loan that is given as a relationship here. So when you consider branches here, bank is related to bank branches via your relationship branches. So one to many, and when it in turn turns from bank branches to bank, it is one to one relationship. So this is how we identify. So by the help of in this diagram itself, they will identify it is given as 1 to n and 1 to 1. Okay, a bank can have n number of branches. That is meaning it can have a branch, so many number of branches in its locality. But bank branch can be associated with the bank only once. Okay, a bank branch cannot have, or it cannot be connected. For example, you have a bank branch. It cannot be connected to many number of banks. It will be associated only to one particular branch. For example, if you have a SBI bank, and if it can SBI can have a number of branches, but not the other branches can have so many number banks that is associated. And next one is your bank branches. So a bank branch is associated with an account. Okay, every branch can hold n number of account. Okay, so it is not necessary that bank branch should have an account. It can have a number of entity that is associated, and each entity can hold a account entity which is associated with them. Okay, and next one is that your account details. Okay, so your account can, every customer can hold one particular account. Okay, so account, if you have a database named account, the account database can hold all the customer values, but only a customer can have only one account that is associated with the branch. Okay, so if at all, if he is having partial account inside that, for example, we can have savings account or fixed account, so many account, okay, or current account, so many account, but it is all associated to only one account number. And next one is that he can have a loan. Every customer can have an option or opt eligibility to apply for a loan. Okay, so here 1 to n, a customer can have n number of loans. Okay, you can have avail a personal loan, or he can avail a housing loan, or any number of loans he can avail. And next one is that he has number of loans that is associated with the help of your branches. Okay, so the branch can avail n number of branches can be given. Okay, so the loan is considered, so based upon the relationship loans it can be associated. Okay. So the branch, the list of names. So here they have just asked for the constraints of each participation of an entity type in a relationship. So there are so many number of relationship that is given here. So branches, account, loan, loan account, and the normal loans which are available. So so many number of entities that is being given inside this particular image. Next one. Next question is that list concisely the user requirements that led to ER schema diagram. Okay, so they're just asking why an ER diagram has to be given. Okay, so here they have just given the solutions also. The requirements can be stated as follows. Each bank has a unique code. Okay, so as we already know, every bank holds a unique branch number. Okay, unique code, name of the person and the address, name of the bank and then the address. Each bank has one or more branches. Okay, so it can have one or more. With the help of this diagram, you must be able to identify and write what are the requirements. Okay, so here you have only one bank, and the bank has one or more branches. Okay, so it can have n number of branches. So here they were just depicted the value n, which is meaning that it can have n number of branches. And third one is that it has its own branch number and the address for that particular branch. So the branch address for each and every bank branch differs. And next one is that each bank branch has 0 or more loans. Okay, so every bank branch can hold n number of customers. So that customers can hold your n number of loans that is associated. Either the customer can have 0 loans, or he can have 2 to 3 loans, 2 to 3 loans that is associated along with it. And each account has a unique account number. Okay, every person will have a unique account number and the type of account. Either it can be a savings account, or it can be a fixed account, a current account, or something like that. The balance of each and every account differs. It is He is associated exactly to bank branch, any one of the bank branch, at least to, or if there is one bank branch, it must communicate with n number of customers, right? So ஒரு பேங்க் பிரான்ச்னு இருந்தா ஒரு கஸ்டமராவது இருக்கணும், otherwise there is no use, right? So if there is one bank branch, and that bank branch should have at least one customer, otherwise the use of having the bank there is, it is pointless, right? So this is how you have to identify with the help of your ER diagram, and then depict what is given there. Okay, what is the unique values, and how, what are the, based upon which requirements they have come up with this ER diagram. Okay, and next question, along with that, they have just given a few more points. That is, your each loan has unique loan number. Okay, so yes, we have just missed out with this loan entity. So here the loan has and unique loan. Okay, so it has a unique loan number. Every loan has a unique loan number, right? And every other, not only the unique loan number, the number of payments that has to be made, the number of payments that has been scheduled via your transactions. Okay, so each and every loan detail has to be maintained in one particular branch, and that is related to your bank branch, because every customer is related to some other branch, right? So they have to be given it correctly. Next one is your, each customer has a unique SSN number, name, address, and phone which is related to him. Okay, he can have his name, address, phone, and his you should have at least one account or zero accounts. I mean, one account means, I mean to say, it's loan account, one loan account, or zero loan accounts that is associated with it. Now, another question, suppose that the next question is that, suppose that every customer must have at least one account that is restricted at most of two loans at a time. Okay, and that a bank branch cannot have more than 1,000 loans. How does this show up in a min max constraint? So they are talking about your min max constraint here. So either it can be one to many, or one to one, or one to 1,000. So if there is an account, the customer can, the account entity can have n number of customers that is associated to him, right? So they call it as your, the minimum value is 1, the maximum value is n. Okay, you can have n number of customers inside your bank. Okay, next one, they are just taking loan as an entity, and with the loan and customer relationship here, one customer is eligible either for one or two loans. Okay, he can either avail one or two loans. He can have an housing loan, he can have a personal loan, or three loans based upon the bank, not more than that. Okay, so based upon this condition given here, a loan, it can be given to n number of customers, but the customer is eligible for having only one or two loans that is associated with him, either your personal loan, or your any other loan, housing loan, or any loans that is with your appreciating asset or a depreciating asset. Next one is that they want to show up the min max constraint between the loan and the bank branch. Okay, if there is a bank branch, it can have n number of customers, and the bank branch is eligible to offer thousands loan to the customers. So it is depicted as the minimum value as 0 and the maximum value as 1,000. Minimum value is 0 and maximum value is 1,000. So a person, so if you want to identify every other image, okay, so when you look at this image itself, you will be able to identify the constraints that is associated, the minimum value. For example, if you consider bank, branches, and bank branch, okay, based upon this relationship, a bank can have n number of branches, so it is one to many relationship. So same way here, if you are taking the relationship in between each and every other entity, it always have a constraint. Okay, it have a minimum value or a maximum value constraint that is associated along with it. Okay, so this is how you identify each and every constraint. So based upon one particular image, if they are asking so many number of questions based upon the constraints, based upon the constraint, you have to identify the constraint. Based upon the requirement, you have to identify how many number of entities that is available, associated, or the relationship that is happening between these entities has to be identified, and the number of attributes, the type of attribute, either it can be a primary attribute or a single valued or multi-valued attribute, and the relationship has to be a weak relationship or strong relationship has to be identified. The requirements has to be listed down. And next one is that the relationship and the min max value that is associated with each and everything, and what are the constraints for each and every relationship. When it happens, when it communicates with one another, the relationship has to be given there, and the constraint based upon the relationship is weak or strong has to be identified. Okay, so next we are just, so I'll just show you two more examples. So we just saw end-to-end relationship. And so here when you look at this image, you have your end-to-end relationship. So an employee is given there and is deputed to one particular department. So the relationship, the employee is a one single person, so it becomes a one-to-n relationship here. So each and every entity can hold n number of attributes, and the primary key attribute is given here is as employee number. Other than that, he can have n number of attributes, like he can have his name, his mail id, his religion, or so many details that is associated. So here the primary value here is employee number. It can, if the employee table has the department id in this table, it becomes your foreign key attribute. Okay, so here the foreign key attribute of department, I mean the department entity holds a primary key attribute, that is your department id. So this is how you depict one simple procedure. So based upon the requirements, we can draw our ER model with n number of entities. The important rule here is that your entity should not be repeated, and your attributes has to be given in a specific manner. Okay, so the based upon the values that is associated with your attribute. So here with this example, we'll just close the session. Uh, with the ER model. Okay, so this is a simple example of depicting what an ER model looks like. A bank example. So here the bank details are just given here. So with the help of this, you can identify, so or you can recollect what all we have just gone through: identifying an attribute, identifying an entity, identifying a relationship, and the values and attributes that is associated along with this. Thank you.